Good afternoon, Year 11. Our new topic is classifying and representing data. This video deals with data collection, which you'll find in exercise 7A of your textbook. Our learning goal is students describe and use appropriate data collection methods for a population or samples, and this comes straight from the syllabus and is the dot point that we'll be addressing today. There are 6. I hope that you've got your notes printed out and that you're filling them in as well as we go. There are 6 stages to completing a statistical investigation. Step 1, posing questions. Step 2, collecting data. This is specifically what we're going to be focusing on today. And there's a number of different methods for collecting data. A census is one way that we'll talk about in a bit more detail in a moment. And a sample is another way. After you've collected the data, then you organise the data. For us, this is done using a frequency distribution table. And then after you've organised it, we want to display it. So some of the ways that you would typically see your data displayed might be in a column graph, might be in a sector graph, might be a line graph, etc. After you've displayed the data, then you can analyse it and draw some conclusions. So this is where you'd be looking at things like analysing the mean, the median, the mode, so measures of central tendency, and also the range as well. And then after that, you write the report. So in total, 6 stages to completing an investigation. So let's focus in on stage 2, collecting the data. Well, data can be collected in 2 ways, a census and a sample. Right, let's make some notes on census. What is a census? Well, it's a survey of every person in a population. Okay, so if you're wanting to collect data from Australians, a census would be collecting data from every single Australian. If you're wanting to collect data from one class, you would need to collect data from every single person in that class. So it's a survey of every person in a population. Let's make a note of that. The other way is a sample. Now, a sample is obviously only part of a population. So, for example, a sample of the school population is the students in your class. And you can make estimates about population based on a sample. Now, obviously, samples are cheaper than censuses because you're not having to ask every single person, but they're also not as accurate. And you can have bias as well. To have a good sample, it needs to be an accurate representation of the population, but it also needs to be small enough to be manageable. So let's make a note of what a sample is. Now, there are different types of sampling. You can have a random sample. You can have a stratified sample. And you can have a systematic sample. So let's have a look at this example below. It says in each of the following, state if the information was obtained by a census, so asking every single person, or a sample, so only a portion of the population. A school uses the roll to count the number of students absent each day. Okay, well, we don't just want to know a sample of the students who are away. We want to know every single student who is away. So this would be a census. B, the television ratings in which 2,000 families complete a survey on what they watch over a 1-week period. Okay, well, we're not asking every single person who watches television, just 2,000 families. So this would be a sample. C, a light globe manufacturer tests every 100th light globe off the production line. Okay, so they're only testing every 100th light globe, so that's a sample. And D, a teacher records the examination marks of her class. Well, the teacher wants every single student's marks in her class, not just some of them. So that would be a census, every single student. All right, let's focus in on sampling, on our 3 different methods of sampling. Method 1, a random sample. Now, a random sample occurs when all members of the population have an equal chance of being selected. Let's make a note of that. Three students from a school are to be selected to participate in a statewide survey of school students. There are 750 students at the school. To choose the participants, a random number generator is used with the results 0.983, 0.911, and 0.421. What are the roll numbers of the students who should be selected? All you need to do is multiply your decimals by the number of students in the school. So do that now, and we'll find the roll numbers of the students who should be selected. The first one is 737.25, but hang on, you can't have 0.25 of a student, so you always need to round up, okay? It would be 738, okay, would be the first roll number. The second one, 683.25, but hang on, we don't want 0.25 of a student, so always round up. 684 would be the next roll number. And the last one, 315.75, so our roll number is 316. Now, if you're wondering how to generate random numbers on your calculator, use the shift button and then press this button down here. You can see that this says random number, and then all you need to do is press equals, 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 and you'll be generating random numbers. Method 2, a stratified sample. Now, a stratified sample occurs when categories or strata of a population are chosen, and then members from each category are randomly selected. All that means is, if you're surveying 100 students, and there's more boys than girls in the school, then you need to make sure that in your survey, in your sample, you're picking more boys and more girls in proportion. And we'll look at that in this example. So making a note of what a stratified sample is. A sample taken in proportion. Alright, Adrian is conducting a survey of school students. At his school, 47% of the population are male and 53% are female. So if he decides to survey 60 students, obviously he needs to do that in proportion so that it's fair and representative of who he's surveying. How many students of each sex should he choose if he decides to use this particular method? Well, he needs to survey 47% of the 60 should be boys. So putting that in your calculator, 0.47 times 60, 28.2. So you will have 28 male students and 53% of the 60 students should be female to represent the whole population. So 0.53 times 60 is 31.8, so 32 female students. Okay, does that give us a total of 60 students? Yes, 28 and 32 is 60. The last one that we'll look at is called a systematic sample. Now this occurs when the population is divided into a structured sample size. What that means is you might select, if your sampling is done with a rule, with a system in place. So you might sample every fourth item that comes off the production line, or every 100th, or every 200th. It's just done with a rule. You might sample the item every 30 minutes or test the machine every hour. It's just done with a particular system, a particular rule in mind. So let's make a note of that. So please use exercise 7A, all of the questions, to practice your learning goal, and particularly make sure that you have a look at the past HSC questions. There was one from 2017, 2013, two from 2012, and one from 2009 that relate specifically to this video, collecting data.